Hello and welcome to video number 3 in lecture number 2. What we're going to talk about now that we've covered variables, assignment statements, and getting input from a user are some odds and ends that we mentioned but didn't really talk about. And the first one we're going to talk about is numeric data types. We are also going to cover type conversion and rounding. This sounds like a lot, but it's really not. That was not supposed to rhyme. All right, so in Python, we have two data types for working with mathematical functions. And a data type is just exactly what it sounds like, a type of data. We're going to have a whole chapter about data types later on, but for now, just know that we have two types of numbers in Python. We have integers, and we have real numbers. An integer is basically a whole number. And in Python, we use int for short. This is what it is called in Python, is an int. Examples include 4, 3, -1, 756, etc. There is no decimal point, no fractional part of an int. That's why it is a whole number. The other type of number that we work with are real numbers. You may remember this from high school math, but this is basically a decimal number or a fractional number, any number with a fraction, or a floating point number. Now, we'll learn more about what floating point numbers are much later, and you'll cover that in later classes as well. But for now, just know that a floating point number is, for our purposes, a decimal number. And because it is a floating point number, in Python, it is called a float. I'm just going to go ahead and bold that. Bold that. Whoops. And some examples of a floating point number, or a float, are 5.5, 436.27, -13.01, and let's say 2.0. Note, it does not matter if the fractional part of a float is 0, like in 2.0. What matters is that there is a decimal point. So this is a floating point number. Even though there is no fractional part, it is written as a floating point number. The way it is represented in memory is different than an integer. We don't need to worry about that though. For our purposes, we just care about if there's a decimal point, it is a floating point number. So, if we come over, and I'm using Trinkets now, and take a look here, we can look at some of these. Now, what I'm going to actually do is I'm going to show you how to do some type conversion and use some of these built-in data types. Okay? So both int and float have their own methods or functions in Python. So we have the int function, and we also have the float function. Not only are they types of numbers, but they also are functions. So what we can do is, let's take a look. Let's do something like print 3 times 4.5. So when I hit run on this, I'm going to get 13.5 because 3 times 4.5 is 13.5. If I do print 3.0 times 4.5, I'm still going to get 13.5. When we do this statement, when we use this mathematical expression, 3 times 4.5, you'll see we have 3, which is an integer, times 4.5, which is a float. And in the second one, we have a float times a float. Whoops, not a float, a float. But they come out with the same number. When we do this first one, Python automatically notices that this number is written as an integer, as an int, and it will automatically convert this to a float or a floating point number. We don't see that happen, but that's what happens when Python is doing this multiplication. Here we've already written it this way, so Python doesn't have to do anything. It recognizes that these are both floating point numbers. There's also some other stuff that's going on here, but we'll talk about that when we get to our chapter on data types. So if you know a little bit more about type conversion and you're saying, hey, wait a minute, that's only half true, or there's something missing, we will get there, don't worry. So for our purposes, we have our int and our float. Cool. Now let's take something like print 3. All right, and I'm just gonna go ahead and we'll leave this here. If I go ahead and run this, it's gonna print out 3, which looks like an integer, right? Let's do this. Let's use our float function and print the converted float version of 3. And you'll see the first one still prints 3, just the way it looks. And then the second one is actually going to print the float version, the converted float of 3, which becomes 3.0. So even though, again, there's no fractional part of this, we still add the 0.0 because this makes it a floating point number. You might wonder, why does this matter? And that's, again, something we don't need to cover right now, but it's the way that it is represented on the back end, as it were, or under the hood. But for our purposes, we just need to know that when we convert to a float, we have a decimal number, etc. Now, we can do this the other way, too. We could take, let's say we had a number like 4.2. Oops. And I wanted to make it an integer. If I make this an integer, so in other words, if I use my integer function on 4.2, it is going to print just the whole number. So you'll see I have 3 from my first statement. I've got 3.0, which is my converted version of 3 to a float. And then I have my converted float to int. So we're going to say float to int. This is int to float. And I'm just going to asterisk that because that is slightly different, but we'll talk about that later. And this is just an int, same thing. So we have float to int, and when we do that, it becomes just 4. Now the other thing is, if I were to have, this does not round the number, so if I had 4.9, okay, which is still float to int, I'm still only going to have 4. It will not round up or down, for that matter. Technically, it always rounds down. You can think of it that way. It's not unlike floor division, when we talked about being on the bottom and it rounding down to the floor, so to speak, when we do floor division or integer division. That's kind of what this is. It's only going to give us the integer part of it. If we want to actually round, and I'm going to go ahead and just comment these out, we can actually use the round function. Whoops. So I'm going to go ahead and I'm going to use my print again. And we do have a built-in round function to Python. So now I'm going to do round 4.9, and this time it is going to actually round up and give me the nearest integer. It will round up to the nearest whole value. Notice it will not give me 5.0, it will give me 5. The other important thing to note here, so we have int, float, and round. And int and float are both data types, and round is a function, as well as their int and float functions. Now, another important thing to note, and I'm just going to remove the stuff, so feel free to rewind the video if you want to go back and look at it again. The variable being converted doesn't change. So what do I mean by that? I was just doing direct values. I was using what we called literal values. You might remember from video 1, right? I was doing stuff like print 5 or print the integer version of 5.5 or 4.5. But what we want to actually, let's say that we have a variable. So let's say we have a variable named mynum, and it is 5.6. And then I do print mynum. Obviously, Python's going to print 5.6. Cool. Let's say I want to convert this, though. And I print the integer version of mynum. Now, based on what we just learned, take a second and think, what do you think this second statement is going to print? So print, and then we have int mynum. And remember, like we mentioned in the second video, you can always look at this from inside out. Just like you would in any mathematical expression, the parentheses are always going to come first. So we have inside the first parentheses, we have, or the most innermost parentheses, we have our variable. Then we're going to take our variable and we are going to convert it to an integer. And then we are going to print it out. So what is this statement going to print? Let's go ahead and run it. It's going to print 5. Again, it's taking this variable, converting it to an integer, and then printing it out. Now, even though we have printed a converted version of mynum, do you think this original variable actually changes here? Have we actually changed anything in this statement? Let's find out. So after we run this, we're going to have one more statement to print our variable. And let's see what happens. And as you can see, when it prints again, it is in fact still 5.6. Whoops. And that is because we haven't actually changed the main variable here. We changed the way it prints here, we converted it here, we converted this instance of it, but the actual variable itself remains the same. In order to actually change the variable, we would have to say something like mynum equals int mynum. Then, if we print this out, I'm going to run all of those again. So this is 5.6. This is the first one. Then we convert it to an int and print it, but we don't actually change anything. We reprint mynum just to see what it's going to print, which we found out was 5.6. Then we have a statement here that says mynum equals int mynum. And remember, this is an assignment statement, so we basically said this variable is now this expression. And this expression is the integer version of mynum. So then when we print it again, we now have 5, and we have actually changed the variable. And that is how we do type conversion for floats and ints to numeric data types in Python. We can also convert strings, but we'll go over that a lot more when we get to Chapter 4.